Morning! We are the group 2 from O4A. So we are going to present to you our fruit identifier. Next to me is
Espiritu.
I am Vedder Sanohan.
Guantero.
Arneil Rodelas, Anoyo.
We are group 2 with fruit identifier. At first, you will see the Philippines as a tropical country that has lots of resources and abundance of fruits. But not everyone knows what these fruits are. So we are going to present to you the fruit identifier. The fruit identifier is a image processing project that would identify the fruits that would be captured using an IP camera. And here to explain our objectives is Guantero.
The objective of our project is to teach kids different fruits that can be shown via image processing like apple. Our objective is to classify different fruits, to display the nutrient facts, and to function of the image processing.
Scopes and limitation. Our scope is that we use image processing, deep learning, and we have an output that the fruit will be scanned, and also it will display its nutritional facts. And our limitation is that our project, we cannot process the fruit at the same time. And the number of fruits installed to our database are limited to just 4 fruits.
For our flowchart, we will start of course on top. Next is the detect camera via IP camera, which is our phone. And next is we will capture the image of the said fruit. We will count the RGB or red, green, blue, converts the image to grayscale, creates the binary image testing, mass filter image from binary testing, count diameter via unit length and pixel. And then there will be a decision which will compare image to sample pictures if approximately same. If it is yes, then output is collected values and classifies the fruit. If no, then it will be an unknown. And if the decision is no, it will be classified as an unknown fruit, which will now end the flowchart.
Now I will discuss the functionality of our application.
In here, we can see the open function of our codes, wherein we will initialize the access one, which is in here, in this big box. Then we will declare the URL of our network. As we can see here, it is 192.168.1.1.36 and 8080. This is the URL wherein it is in the shot.jpg. Then we will include it in our imread parenthesis URL. In here, the draw now function as so we can preview the video, the live feed video here in the access one. In here, we can see the button called testing data, where we can see its function by initializing the first fruits like lemon, oranges, apple, and the Indian mango. Then we will include it as lots of feature, wherein this is the different types of apple. And in this code is for the getting of the image file of the selected image. Then our code will read the image that as have been read by our code. After selecting the file, it will show here in our image testing access. It will output the selected file there, and then it will compute the pixels of each of the selected file in red, green, and blue. Then this is a built-up code to count the number of pixels that are equal to red, green, and blue. Then it will convert the image into grayscale. This is also a given code in MATLAB. Then the grayscale will be converted as binary image testing. In this part of code, we need the grayscale testing in here. Then this process is max filter image, wherein we need the binary image testing to use this as part of our code. After that, the process will be the count diameter of the image. Using the max filter image generated here, the output here will be used in our diameter compute, which is in terms of length in each pixels. In this set of codes, gagamitin natin yung image processing na na-generate niyang output at saka yung deep learning, kung saan yung mga output ng image processing ay gagamitin at pagkukumpara sa aming deep learning, which in this, makaklasify nila kung anong klaseng fruit yon. For example, if it is detected lemon, it will output the nutrition facts by it, and so on. Orange, apple, and Indian mango.
Wait.
At kapag hindi niya na-classify kung anong fruit yon, sasabihin ng aming application na unknown siya. And this line of code is to capture the image. And we can see here, this is the button of capture photo. Kaparehas lang siya ng preview. Nagamit siya ng URL which is initialized as global. Yung ginamit ng una ng 192.168.122. And tapos kapag nakuha niya yung image na to, ilalagay niya ito sa file name.
So based on our findings from our research about image processing in identifying fruits, we were able to exercise our knowledge about image processing and apply it in identifying the fruits that had its picture taken using the IP camera installed on the mobile device. The fruits were identified properly and gave the proper nutritional facts about it with the help of image processing and machine learning. We were also able to use to make MATLAB and a mobile device communicate with each other using add-ons on hardware support for IP cameras. Okay. For future proponents, we recommend a more efficient way in machine learning for the fruits, a better graphical user interface that is user-friendly, additional nutritional values such as calories, fat, and other health-based values, a more accurate image for image processing, a better camera, and use a more powerful computer that has at least 8 gigabytes of RAM and an i5 Intel Core processor or higher, or with the same specifications like Ryzen for the processor, and a high pixel camera is also recommended for better identification for image processing. Thank you for listening to our discussion about image processing, and God bless you.
Yeah.